In this video, we will be graphing this rational function. Let's start with the x-intercepts. I don't know why there's a 5 sitting right here in my way, but just pretend it didn't exist. Let's consult our notes. According to our notes, we can find the x-intercept by finding the zeros of the numerator. In other words, set the numerator equal to 0 and solve. So that's what we will do. Finding the zeros of the numerator. So if I set this numerator equal to 0 and solve, what I like to do is factor this. So that would be x plus 2 times x minus 2. Setting each of these equal to 0, x plus 2 equals 0, x minus 2 equals 0. That's going to give me x equals negative 2 and x equals positive 2. Alright, my x-intercepts are always going to be something comma 0. Okay, so these are just the x values of my x-intercepts. So negative 2 comma 0 and positive 2 comma 0. These are the x-intercepts. And I might as well go ahead and graph those on my graph right now. Okay, so negative 2 comma 0, boom. And positive 2 comma 0, boom. Now let's talk about the y-intercept. For the y-intercept, it's always going to be 0 comma something. So I can find the y-intercept in two ways. If I know that it's going to always be 0 comma something, I'm saying that the x value is always going to be 0. So I can either plug in 0 by hand or use my calculator. But wait a minute. If I put in 0 right here, if I substitute in 0, I'm dividing by 0. That would be like having negative 4 over 0. This is undefined. Okay, and that's not okay. So that means there won't be a y-intercept. So later I'm sure we'll find that there's an asymptote, a vertical asymptote there, and that's why there's no y-intercept. So we're just going to say none. Okay, no y-intercept. And if you were to put this function in your calculator, which is the other way that we look for the y-intercept, that would work like this. You go to your table feature, type in the function, and I think we had x squared minus 4 over, was it x squared? I forget. Yeah, over x squared. Okay, I'm going to leave it in ask mode, ask x. So if I substitute 0 in, just delete this, notice I get an error. That's because we're dividing by 0, and that's not okay. So usually means there's an asymptote. So speaking of asymptotes, let's go ahead and talk about that now. Okay, vertical asymptotes first. We get vertical asymptotes by finding the zeros of the denominator, setting the denominator equal to 0 and solving. That's how you get vertical asymptotes. So I will set the denominator equal to 0. So that means x squared equal to 0. You would then take the square root. That's just going to be x equals 0. So we have one vertical asymptote at x equals 0. Normally I do plus or minus, but plus or minus 0 is still 0. So don't just put 0, put x equals 0. So go ahead and draw the vertical asymptote as a dotted line. Okay, we could do the domain right now, just based on the vertical asymptote. It's going to be negative infinity to 0 and then 0 to infinity. Alright, the domain is only broken by these vertical asymptotes. So negative infinity to 0, union 0 to infinity. What about the horizontal asymptote? What's the deal there? Well, we have learned that the horizontal asymptotes depend on these three rules. It's all about the degree of the numerator compared to the degree of the denominator. If the numerator degree is less than that of the denominator, it's y equals 0. If the degrees are equal, then it's y equals a over c. These are leading coefficients. If the numerator degree is greater, then there is no horizontal asymptote. You have to memorize these three rules for horizontal asymptotes. So the degrees are the same, so therefore it's going to be a over c, leading coefficients. The leading coefficients are 1 and 1. So that's why the horizontal asymptote is 1, because 1 over 1 is 1. So we should have a horizontal asymptote here at y equals 1. Notice, put y equals 1. Don't just put 1. Don't put HA 1. It's got to be y equals 1 or you're losing points. We cannot do the range without more information. You can't do the range just based on the horizontal asymptote like you can with the domain and the vertical asymptote. So we're going to need to go ahead and do the graph now. So the first thing to do is to decide which x values you're going to use. And to do that, focus your eyes on the vertical asymptote, or asymptotes if you have more than one. Our vertical asymptote is at 0. So that makes this problem pretty simple. Since the vertical asymptote is at 0, we definitely want to use the decimals, 0.5 units to the left and right. So to the left of 0 would be negative 0.5, and to the right of 0 would be positive 0.5. We want to use those. We're going to get two more values by going a little bit further left and right. So if I went further left, I'd have negative 1. If I went further to the right, I'd have positive 1. Okay? We have plenty of space on this graph, though, and we don't have any other vertical asymptotes. So I'm just going to keep going further to the left and right. So I would go to negative 2 and positive 2. All right, that's 6 values. I would do negative 3 and positive 3. That's 8 values. Let's see, 1, 2, 3, 4, 5, 6, 7. I'm just going to add an extra square on here so I can have 8 values. Okay, so these are the 8 x values I'm going to use. I'm just going to write them here now. Alright, so I wrote all my x values down. Now I'm going to use my TI-30XS multiview to help me find what these values are. So I have it typed in. I'm going to be in Ask X mode, and I'm just going to start typing in each of these x values, and I'm going to find the y value. We'll do the first 3 together, and I'll do the rest by myself. So if I type in negative 3, negative 2, and negative 1, for example. Okay, negative 3, negative 2, negative 1. So that gives me these. 5/9 is a weird fraction, so I'm going to highlight it, toggle it, I get the decimal. I'm going to round this to 0.6 because the next number is 5 or higher, so you round up. So 0.6. So I have 0.6, 0, and negative 3. Okay, so I have 0.6, 0, and negative 3. Okay, so I will go on and type in the rest of these x values and get the y values to go with them. but I'll do that off camera. Okay, so these are the y values you get. You can probably see the symmetry that's happening even from the chart. So it'll be interesting when we graph this. I expect to see some symmetry in the picture. Alright, so I'm just going to plot these points on the graph and get an idea of what it looks like. Alright, so as you can see, I've plotted these points. I had to go off the grid a little ways because at negative 0.5 and positive 0.5 I was at negative 15, but I could sort of estimate about where negative 15 would be. But hopefully you can see the symmetry that's happening here as it's going to the left and to the right. You can see a mirror image is forming. And you can see the way that it's approaching the asymptote in this fashion. Alright, it's going to be doing something like this. Okay, and this one is going to be doing something like this. Okay, that's what this graph is going to look like. Now, as far as the range, this graph goes from negative infinity up to 1. It reaches all the way up to the horizontal asymptote. It doesn't touch it, but it goes from bottom to top. It goes from negative infinity up to this asymptote. Okay, so the range will be negative infinity to 1. And because it doesn't touch, we'll leave this round parentheses. Now, increasing and decreasing intervals. From left to right, it starts off decreasing. And we have to pause because it doesn't reach this asymptote. It never reaches it. So if I'm looking at the x values, though, it's starting here from negative infinity. Okay, it's starting from negative infinity. And this branch continues until it gets to the asymptote. So it's negative infinity to 0 is my first decreasing interval. So negative infinity to 0. These are only x values, so keep your eye on the x-axis. Negative infinity to 0. Now, then it picks up here on the other side, and as I go to the right, it is now increasing. Okay, so it picks up where it left off at the vertical asymptote, so it's going to pick up at 0, and it continues increasing as it goes to the right, and it goes to the right forever. So again, looking at the x-axis, it starts from 0 and it goes to the right forever, so that is 0 to positive infinity. So those are my increasing intervals. Now this does have even symmetry. Alright, the choices were even, odd, or neither. It's even when the y-axis splits the function perfectly right down the middle. And as I pointed out on the table, you can see the balance between these numbers that match. So every point has a mirror image across the y-axis. That makes it even. Remember that odd would be one that looked the same even when you turned it upside down. You know, so when you have a function that's like this, and if this is the origin, this would be odd, for example. But that is it for problem number 4. I hope this video was helpful.